Now we are recording. Now, okay, the intention is, or the job here, or the task or inquiry we're going to do now is to have these two heat exchangers combined into one frame. The idea with this inquiry is to heat this milk from 4 to 30 with some water at 40 degrees, and that's 28 cubic meter per hour. If we then look over here, we can see that we are heating with steam these 28 cubic meter of water from the outlet here, which is around 20 up to 40. So this water circuit flows to this heat exchanger. What Bojan and Jelena have done is here they have a QO34 dual flow in a painted one, and they have a H17 here in a stainless steel version. Since this one is probably standing in the dairy, and this one here could, I suppose, be standing in the utility room since it's since the selection has been painted. But the customer has asked Bojan and Jelena to build these two heat exchanger into one, which will save space, plus it will also reduce the whole cost of the equipment. One heat exchanger with one frame is cheaper than two heat exchangers. That's for sure. So what I will do now is I will open this calculation here done by Bojan, and it's called, what is it called? It's easier to double click here and then, oops, copy the ask number. And then start page, and then open. And then calculation. I believe this was the one, this revision number 4. Yes. You just correct me if I'm doing something wrong, Bojan and Jelena. I'm just doing assumptions, so it's your job to stop me if I'm doing something wrong. Okay?
Okay.
Yeah. First thing, when we open an existing ASK file, is to say edit all, because we are pulling it in from the server. Now, and then you can see here you have a red revision line here. The reason for because it's red is because it's outside validity date. But when we make a new revision, because I'm going to do a new revision here, when we make a new revision, it will automatically put in the dates from today and 1 month ahead. So I'm doing add revision from current. And see, now it's for the 10th of March. Then obviously we cannot have a requested delivery date in September last year. So this one has to be pulled out to something realistic. So I press here for today's date, and then I add a couple of months. So now it's in April. Then I save. Now prices has of course changed because this one was done in 21. So price date has been changed. Price on all items will be recalculated. Yes, perfect. Sadly, it went up in price, but it's not a surprise. One way of doing it, since we already did, or Bojan already did a design here for the heating of the milk, I think it's a good idea to keep this as an item. We can delete it afterwards because now we're going to do an item with 2 sections in it. But I will keep this one so we can go up and look at what Bojan did in this specific section. So what I'm going to do now is I'm going to do a new item. Obviously, we are now going to have a 2-section heat exchanger, so it cannot be from current. We need to do a blank one. Then I can call it 2 SECTUN milk preheater, and then PHE. Save. Then green arrow. Process application. It's a sanitary, so it needs to be multi-section, A4. We need stamping of the plates. It's PED. It's a thin product. Actually, I don't know what you did, Bojan, if you did it in sanitary or industrial. You did it in sanitary, then I will do it in sanitary. Sanitary standard. Save. And now the tricky part comes. So now you have to listen carefully. See, what we're going to do now is 2-section, and that's what we call multi-section. I will just name this one number 1. I always do that. So this is liquid-liquid countercurrent, 1 section. If we want to do a multi-section, we have to press here on the drop-down menu and then select multi-section. Then the program automatically draws in 2 sections. Then, as I don't know if you remember, but this heat exchanger was a steam heat exchanger in the first section, and the other one was where we want to heat the milk. So we can keep this one here. I will close it down. So this is a liquid section, milk, water, but this section has to be a condensation section for the steam. So this one I will call condensation. And it can be called section 1 or section 2, or you can call this water heater and product heater. Could be something like that. Then I will start drawing up the way I want the streams to run. And when you have a steam section, it will always start with the steam. If you start entering in streams in this section. So what I do is I press this question mark, and then it automatically draws in the steam stream. Then the next thing that I'm going to draw in is my water circuit from this section going to this section. So, and please make a note of which way the arrows are flowing, so you do it in countercurrent, if that's what you want. So here I do the inlet of the water, And note, this one is not filled out, this stream here. That means it will continue to wherever I want it to continue to. If I press here, the green one, or this unfilled in arrow, it will make an out, it will finish the stream, and then this stream is finished. I will delete it again. The way you delete this stream is put yourself on the stream with the mouse and then right click, and then you can say delete. So now it's gone. So now I will start again. Inlet, then I want an outlet for this water to go into this section. So I press here. Then this water is flowing here and then out. Now my water stream is finished. Then finally, I'm gonna make the milk stream, the milk we're gonna heat. I'm gonna do that here. And note, since it's the last stream, it automatically made an outlet. Here. Then now it's a question of entering in temperatures and flows. And here, when you're doing it for multi-section or several sections, it is even more important that you use the tabulator when switching between the input fields, because it's a lot easier to do it that way, or else suddenly you will have put in too many information or too less. So I start here with my steam, and I say steam. Oops, that's wrong. Then when entering in steam, most of the cases, we don't know the steam flow and we want the program to calculate that. But we know the saturation temperature, and let's see what Bojan did. He said 143 degrees. So we put in 143. Oops. And then it automatically fills in the fields with the pressure and inlet and outlet. Only if you're using the steam, if you're doing a steam heat exchanger, heat exchanger, where the purpose is to condensate the steam, you change the outlet temperature. But if it's not, you just keep the temperature that the program automatically puts in for you. Again, I'm using the tabulator. Steam, I always put in 0.5 bar. Then I used the tab. The next thing was that it jumped to water, to the water side. Then I put in the water. I remember it was 28,000, sorry. And the inlet of the water was 20. And then we want an outlet of 40, heating the milk. Then this field here, just to explain what it is, this field here is DT is if you, for example, have a temperature increase between here and here, or if you have a temperature decrease, you can put it in here. Let's try with, for example, just to show you, -5. Then when it's finished calculating, it should change this to 35. Okay. I used the tabulator. I put in, let's say, 1.5. Since we're going through 2 sections, I increase my pressure drop a little bit. Then this section here was where the milk has to flow. system. Goods, food, dairy products, milk, and milk. And it was it 20 or 22? 22,000 liter. Oops, what happened? Yeah. Then I will immediately change to liter per hour because Bojan entered in liter per hour. So 28. From 4 to 30. 1 bar. See, since I used the tab to swap between all fields, I immediately had the right or valid duty. I didn't fill in too many information or too little, you could say. So here you can see we have 2 unknown, and here we have 2 unknown. It always needs to have 2 unknown in a duty in order to balance and in order to calculate. Please note that this temperature dropped to minus 5 degrees, so it's 35 because I just wanted to show you what happened if you fill in either increase or decrease in this field. I will change this back to 0. So this is actually the duty we're gonna select a solution for. Do you agree, Bojan?
Yes, I agree.
Good. Then, obviously, this cannot be done by auto selection cheapest. And as always, auto selection cheapest do not work on food heat exchangers. So solution and add solution default. And then it's not responding. Okay. Just this. See, the first thing I'm going to change is we have one section where we have 143 degrees in. So obviously and logical, we will get a warning where it says that duty temperatures exceed design temperatures. So the first thing I'm going to do is change the design temperature. 150. All sanitary frames, except a couple, iron, but all others are designed approved to 150 degrees. So if you have cases where customer require higher design temperature, either you ask him to lower, since all ours are designed for 150, or you try to find a frame where the design temperature is higher than 150. Then 150, and then since I don't want to look on Goldsbush, Shidoo, and all other types of frames, you can see here we have different production sites. The palette is huge with different heat exchangers. I don't want to have that, so I press my design filter. Take plant. I take Poland. and I take standard basic. I know you AskFlow people, you all have a predefined filter with these two variants of selections in it. So this is not something you have to do each time. These filters are predefined depending on which customer we have. For some. Okay, originally Boyan selected a H17 for this job, which is fine. So I will try to do the same. So I will change to a H17. And it was an RKS10. Then Node automatically puts in the smallest possible fittings available for this time. And obviously that will give way too much fitting velocity if it's 1-inch connections. I noted that Boyan had selected 2.5-inch or 65 millimeter D, which is a perfect size for this flow rate. Remember the rule about around 1.5 up to 2.5 meter per second on a dairy product. So then I try, and when you do multi-section, it is recommendable to use this one up here. You got a better overview of the connections. Okay, then I try to see if I can select 2.5-inch. Can't remember, was it male parts? I think it was. This one. Okay, what happens here? 65. And it's not changing, even though I have one up here, it's not changing for the other stream here in the grid. This is grid number 1. G1 stands for grid number 1. Remember, we are now in more 2 sections, and hole 4 in hole number 4. But it's not able to change this. Okay, then let me show you. If I go to this size, which is 1.5-inch, then suddenly it changes. Reason for that is, in order to get a bigger connection, we need a grid which with a bigger width. If you look here, you can see that this grid is 45 millimeter. And for 55. And for 55 millimeter grids, you can get 1-inch and 1.5-inch connections when we are in a H17. It's different for other types. So in order for me to select bigger connections, I need to change this grid to a grid with more thickness or width, so I can take a bigger connection. Then it selects an 80. Then I go up here, stream. Then I say here, use the same fitting, and then I try to find the one I had before. This one. Now it changes. And I will select the same for all the connections, if possible. And I think it is. So now we have 65 millimeter DIN male parts for all connections. Then I say, okay. Then these warnings regarding velocities should go away. And they did. We have here 2.7 on the water, and that's not any problem at all. We can go up to 6 meters per second. And on the milk side, I have 2.1, which is also within the range we recommend. Then next thing that we have to do is go to plates and gaskets. And first thing is changing to 316L. And clip gaskets. Yeah. Which thickness of plates did you select, Boyan? Was it 0.5 or 0.6? It was 0.7. Is there any particular reason for going into 0.7?
As I remember, it was the request from the customer.
Okay.
I'm not for sure. I think that was the request from them.
Okay. Okay. Yeah. Then we will just select 0.7. No problem. I will select 0.7. Note that for the moment, I'm just working in the water heater here. The other section, which is the product section, automatically changes my plate material and selected gasket material because I have marks up here. Use same plates all section, use the same gaskets all section. Okay. Now we have a little discussion, or we should have a little discussion about gasket selection for this particular duty. Boyan and Yelena, they have selected for the steam one. They have correctly selected EPDM since we are in high temperatures. So EPDM can go higher in temperature than nitrile, obviously. And for the heating part, where we have the milk, they have selected nitrile peroxide, which is also a logic choice for this product since we are containing, since the product contains animal fat. So we have to come up with something where we have two different gasket materials in our heat exchanger. And then what we do is we click this one off because now we want to do separate gasket selections for the two sections. So we remove this one. Save. Then we keep the EPDM for the water heating section. And then we change the gaskets in the second section to nitrile peroxide. So now we have two different gasket materials. Then we want to, now we will arrange the plate arrangement in the two different sections. We will come a lot more into this when we start doing real steam application at a later stage in the assignments. But it's always a good idea to start with soft plates when calculating steam applications. Soft plates is 60-60 angle. Reason for this is one important thing when doing steam heat exchangers is that you have a free as possible passage for the steam to leave the heat exchanger as condensate, because obviously the steam will condensate in the plate pack and then leave the heat exchanger as a condensate. So always start with 60-30 angle when doing steam sections. Then do not rely on what it comes up with as an arrangement guide here. This is way overkill. So where to start? Yeah, that's the question. But I would say let's start here with, let's try with just 15 on steam, and then I take 16 on water. So I surround the steam side in order to be sure that I'm condensating the whole amount of steam. So I have one more channel on water. So 15 channels on steam and 16 on water. Say okay. See, we have fine excess area. Our pressure drops are low. Can't remember if we have, yeah, I think we looked at that on general design guidelines. When using steam, normal saturated steam above, I would say, 2 bar, we can allow up to 150 meter per second in the fitting. And here we only have 50, so we are home free. But actually we can do this with less plates, since we still have excess area. So I will try to reduce to 10, 11. Still a lot of excess area. 23%. I think we will keep it here. If you look at what it is actually able, it is actually able to heat up the water to around 44 degrees. We could go lower. Let's try. 5 and 6 maybe. See, now we start to create a relatively high pressure drop. Remember, the higher the pressure drop you have on steam side, the more the steam pressure decreases, and therefore also temperature decreasing of the steam. In this case, where we have 143 degrees, it's not an issue. But if you had low pressure steam, it could be critical. I think I will put a little bit more plates into it, because remember here I have 1 bar and on water, and this water is going over here. So if I want 1.5 here in total, I don't think I should have 1 bar in this section. So I will just add a couple of plates. Okay, let us keep it here for the moment. Then we are going to work on the next section where Bojan did a design. Actually, we could, instead of opening this each time, I could go to the selection he did up here, since I kept it in my revision. And I can see he has 2 passes of 18. and all 30-30 angle, thermal hard. So I will try to do the same in this section. The program suggests 2 times 16, so it's what Bojan has selected is actually fine. Oops. Okay. Now we have a section with a plus. We are able, in theory, to heat the milk to 30.4 with this amount of water. Coming from this section into this section, we have a total of, if we add up these two, you can also press this one up here per stream. You can see on the water we have 1.7, we have 0.8 on the milk, and we have 0.13 on the steam. Remember, I entered in my duty, I entered in 1.5 here. So we could add a couple of plates more in the steam section and then get this one lower. So let's try that. Set arrangement. 1 times 9, 1 times 10. Okay, now I'm on 1.5. But now it's giving me some warnings about convention problems overall condensation section, in the condensation section. That means that now I'm actually pulling in too many channels. So I will reduce to 8 and 9. Now warning is gone. In the water section, sorry, milk product section, the milk is flowing. Remember, the milk was the blue one we drawed. That was the last stream. You can see the milk is flowing here in 2 passes and then leaves the heat exchanger. And here I have the water, and I always try to make sure that the last stream is the stream surrounding the product. In this case, the last stream is the water stream, so I will not do 1 extra plate on water. Okay. What is the next thing to check now? Bojan, do you have an idea of what I'm going to check right now?
The CIP.
Correct. I'm just pushing you all each time because I want you to remember the CIP each time. But next time I will not ask you. Then I reckon you remember it, and I trust you do it each time. So solution, define CIP, 85 degrees, and then it's the milk I want to CIP. It's a perfect solution. I need less than my product, which was 22 cubic meter. But I do not have minimum 1.5 meter per second in the fitting. So instead of having the program calculated, this is the needed flow but I will specify, let's say 20 or 22 cubic meter, meaning the same as the product flow rate. Save. So now I have 2 meters per second. So I just went from this one minimum and specified the flow rate myself. Okay. Now we have a heat exchanger with 2 sections. Then let us have a look at how it is arranged with the position of connections and everything. And now it's gonna be a little bit tricky. So just follow. I will do it slowly, and then eventually, when you have done it 100 times, you get used to it. But for me, the logic way would be that this steam section, there's no point in using the grid here. It will be easier for the customer to have both steam connections on head side. So the first thing I'm going to do is move this connection, this outlet, to this position. And please note, steam always have to come in the top of the heat exchanger, or else the condensate can't leave the heat exchanger. If you do it opposite, you will simply just build up condensate into the heat exchanger and you will damage it in 5 minutes. So the first thing I'm going to do is move this outlet to an outlet here in H4. That is done by pressing this one, stream positioner. Then I scroll slowly over the small icons to see and read the text. It says here, change flow inlet on follower side and outlet on head side. Okay, that means that it wants the inlet here and outlet here. That was not what I wanted. Then I scroll to the next one. Change flow inlet on head side and outlet on head side. That was what I wanted. So I press, and then it swaps the stream to this side. Then I say, okay. Now I have the steam here. Then the next thing that I would find logic is that this water, which is going in here, going out here, and then in here, it would be logic that it comes in the same position. So I want to swap these 2 streams to the bottom of the heat exchanger instead of what they are now in the top of the heat exchanger. So I go to steam positioner. And then I press this one and it says, or I look over, I scroll over the icons, and this one, it says change flow inlet at bottom and outlet of bottom. Okay. Now it should be swapped. So now I have an inlet of the water coming in here, going out here, then going here, and then it goes into a double corner bus and then being heated up again. Is this something you can accept, Bojan? Is this an arrangement which is acceptable?
I think it's okay, yes.
Okay. Then I say okay. When doing changes on plate arrangement, always check your connections again, that it has kept your connections. And this is what we selected to begin with. And in this case, it has kept the first selection, so that's fine. So now, Boyan, you have something you can quote and show to the customer. Do you need, I suppose, do you need a spray screen and a spanner on this one, or?
Yes, you can add it.
Yeah, I will add that. Spanner and spray screen. Anything else you want to add, or should we leave it as this?
Some certificates.
Yes. The EC certificates.
Yeah, just
For the gasket and the
yes.
declaration of conformity.
Yeah, and yeah, these two.
Yeah. Okay. Okay. Save. Now I have this 2-section milk preheater, and remember I kept this one just as a test, or so I could see the plate configuration that Boyan did. So actually now I'm going to clean up my ASK file because I'm not going to quote. Yeah, okay. Yeah, you quoted this one in revision number 4 up here. So in this revision where I'm doing the 2-section heat exchanger, I will delete this item. Delete. So my revision number 5 only contains what I'm quoting the customer. Okay?
Okay.
Now you can, after the training, Boyan and Jelena, you can open this ASK file and quote this heat exchanger. But before, I just want to recap a couple of things for the other guys. I want to generate the report just to show you how a report on a multi-section looks like. Report. Come on. Customer data sheet. And I'm saving it on my own folder. And I will open it afterwards so you can see how it looks. Then I go to, yeah. Yeah. This is how a multi-section looks like. Data sheet. It starts with the specifications on the heat exchanger. Then it has the accessories selected. Then it has the CIP flow stated on page number 1. And then second page gives you a small sketch of how the streams are running. And it gives you the process data by stream, steam, water, milk. And then the last page gives you per section, so you can see what is happening in this section and what is happening in this section. In my opinion, a relatively easy data sheet to read and to understand. At least if I compare them to Alfa Laval and especially GEA, these are a lot easier for the customer to read and understand, in my opinion. That's my personal opinion, of course. The Alfa Laval guys will probably say it differently. I will say close. So now I will close this one, and in 2 minutes, 1 minute, Bojan and Jelena, they can pull it in from the server and make their part on it, print drawings and everything. Maybe before we do that, I would just want to show you other guys how the data sheet is going to look on this. Sorry, the drawing is going to look on this one. I will open it right away so we can have a look at it. Bit slow. Up in this corner, like you have on single sections, you here have the description of fluid in each position or connection. You have the description of the type of selected fittings. And when you have a grid in it, it is drawing in the grid. If you had 3 grids, it would draw in the grids in the plate pack. And down here you have descriptions of H1 is figure 1, and the grid connections are in figure 2, which are this one. And then there's a small sketch of the grid, so you can see the grid width of 80 millimeters. On top of that, you have this small 3D figure here, which shows you where you have connections. In this case, you're using H1, 2, and 4 on head side, and you're using the 2 bottom connections here on follower. The other ones are filled in with port blanks. And then you're using these 3 corner box connections. That's how a multi-section drawing looks like. Save. Now close this one, and then Bojan and Jelena can work in it later on today. So I close this one. Was that difficult, or was it okay to see a 2-section machine done?
It is easy when you watch the other guy doing it.
Yeah, I know. But then you must try to follow my recording and see if you can make it similar. At the end of the training course, we will do more of this. But I will stick to maybe 2 sections, maybe 3 sections at the end of this training. Not today, but in a couple of weeks. But it's easy when you look at it correct. But if you do it more and more and more, you get, yeah, of course, obviously more and more used to it. So I will stop the recording now, because now we're gonna have a 5-6 minute break, or at least time enough to go and grab a cup of coffee or a cup of water. So see you all in 5-7 minutes. Okay.
Yep. See you soon.
Okay.